Hello students, welcome to the Computer Organization and Architecture. Next topic. Last class we have discussed execution of sequential instruction. Today we are going to discuss execution of branched instruction. We know the difference between branch instruction and sequential instruction. In sequential instruction, instruction will be executed one by one in sequential manner, but in branch instruction execution depends on the condition of the branch instruction. Along with that, we will discuss multiple bus organization. Previously, we have discussed single bus organization. Execution of branch instruction. Branch instruction execution depends on the condition of the branch instruction. So that for the execution of branch instruction, the program counter should be updated depending on the branch target address location. That is done by adding the branch target difference between the branch target address and the program counter current content. We know that the difference, this is taken as the offset. That means offset will be the difference between the branch target address and the current program counter content. We know that when an instruction is executed, the program counter will point to the next instruction to be executed. But in the case of branch instruction execution, program counter, when the conditional branches becomes true, the program counter should point to the instruction which is residing in the particular branch target address location, so that there is necessary to add the offset branch offset address. Here you can see one example like branch greater than 0 loop. That is an example of conditional branch instruction. Whenever this condition is satisfied, control should be transferred to the loop, transferred to the instruction which is residing at the location loop. Here you can see some sequence of instruction. There is one label loop. In that label we are having one instruction x is equal to x plus 1. There are in between so many instructions. At last we are having branch greater than 0 loop. Whenever this instruction becomes true or whenever it is satisfied, the control should be transferred back to the x is equal to x plus 1 that is residing in the loop. This type of instruction is known as the branch instruction. So that for every instruction execution, program counter will be points to the next instruction which is following the currently executed instruction. So whenever this instruction is satisfied, program counter content should be updated to the instruction which is residing at the branch target address location. To update the content of program counter, it is necessary to add the difference between the branch target address. In this case, branch target address is this address of the instruction x is equal to x plus 1 that should be added with the current program counter content. Current program counter content will be the address which is following the branched instruction, like branch greater than 0 loop. That is done by taking the difference between the branch target address location and the current program counter content. That is taken as the offset for determining whether it should be added or subtracted from the program counter content. If it is a backward address location or forward address location. In forward address location, in some case loop is coming at the address location that will be a greater address location than the current address location, or the feed backward address location is also there. In that case, either we have to add the program counter content with the offset, or we have to subtract the offset from the program counter content. These type of instructions are known as the branch instruction. So in that case, the offset should be determined, and that offset can be either added or subtracted from the current program counter content. Here you can see one execution of branch instruction. Execution, as we discussed, execution of branch instruction is done by, for every instruction execution, program counter is initially pointing to the one instruction. Its control signal becomes program counter, out becomes enabled, so that the content of program counter is fed into the memory address register. Whenever one address location is available in the memory address register, perform the read operation, and the select 4 is used to increment the program counter to the next address location. Perform the addition operation to increment the program counter to the next address location, which is following the currently taken instruction. That is fed into the temporary register Z by enabling the input signal in as set stage, so that the incremented program counter will be available in Z in, and Z out becomes enabled as 1. It can be fed again into the program counter, so that it can points to the next instruction, which is following the currently read instruction. Then during that time, it is waiting for completing the read operation. That is a memory read operation that takes some time for so that there is a wait for memory function completed. Whenever the required time is over, the information is available in memory data register, and before executing the instruction should be available in instruction register, so that the memory data register signal becomes set to 1, so that the content of memory data register can be fed into the instruction register by enabling its in signal stage as 1. That means after the third step or instruction is available in the instruction register. In the case of execution of branch instruction, the offset should be added with the content of program counter to determine the branch target address location that is specified by the offset field of instruction register. That should be added with the ZIN, because we know that ZIN contains the program counter content. It should be updated by adding the offset field of the instruction register. Offset field, as in the case of previous example, offset field is determined by the difference between current program counter content and the offset branch target address location. It should be added with the ZIN. Then Z out is transferred to the program counter content to determine the branch target address location, to specify the target address location, and to read the target address location for the execution of branch instruction. The ALU can access A and B input through bus A and bus B via the multiplexer. A is taken from the bus A and after deciding the whether it should be added with the whether the input should be constant or the input is taken as this particular thing, input coming from the bus A, it can decide what will be the input B. Multiple bus in this slide we can see the advantage of multiple bus organization. For the we will discuss the add R4, R5, R6, that is one addition operation. In this case the addition will be the content of R4 is added with the R5 and resultant data is stored in R6. For the execution of this instruction using the single bus, we need more number of steps, instruction steps, and more number of time cycles are required for completing this task because we are having only a single data path. But in multiple bus organization, we are having multiple data path. We are discussing based on the previously shown multiple bus data path. By using that, it can perform the execution of this instruction. So now we are going to see how the execution of this instruction is taking place by using the multiple bus organization. Initially, program counter out is enabled as 1, then R is equal to B, that is taken as one of the input. Whenever this PC out is enabled as 1, it can transfer the its address location, content of program counter, that is one address location that is fed into the memory address register. Then enable the read signal to perform the reading of that current instruction. Then after enabling the read control signal, increment the program counter by 4 to point to the next instruction. Then wait for memory function, previously executed read operation, wait for that. That should be completed. Wait for some time to complete that memory read operation. Then after completing the memory read operation, the data is available in the memory data register. That means that is one of the instruction which is available in the current program counter. Memory data register. Memory data register out becomes 1. Out is set to 1 so that its content can be, that is actually the instruction that is fed into the instruction register. Then our instruction is then execution of instruction which is available in the instruction register. For the execution of instruction, we know that we are using multiple bus organization so that it can take one of the input from the bus A, another input from the bus B, and it can transfer the resultant data to the bus C. So that R4 out becomes enabled as 1. Take the register, that is one of the register. R5 is another register. Then through the bus, it can the arithmetic and logic unit can take the input from the R4 as well as from the R5. Now two input operands are available by enabling the out signal of both the register as 1. Then select A to determine what should be taken as A. Then perform the addition operation. After performing the addition operation, the resultant data is available. Then that should be stored in R6 according to the instruction. For storing the information, R6 in signal becomes 1 to store the information in R6. Then end of the instruction execution. Now by using these number of steps, we can complete the execution of this particular instruction. But by using single bus organization, more number of time cycles are required for completion. multiple all these things we have discussed earlier for the execution of that previously shown sequence of previously shown instruction execution. The value to be added to the memory address register is the original content. Incremented value is loaded into program counter. Then wait the function completed. Now the last thing is you try to write down what is the control sequence for the execution of instruction add R1 comma R2. By performing this instruction execution, the resultant data should be available in R2, including the instruction fetch phase. Assume that we are using single bus organization like this. We are having only internal processor bus. You have to answer to this question, and that is one of your assignment. And in the next class, or by taking the 1 week time, you try to answer to this question: what is the control sequence for the execution of instruction add R1 comma R2? The architecture, bus architecture will be this one. Thank you.